Hello and good day. In pre-algebra, we'll be covering PO9, adding and subtracting rational numbers. But first, we are going back to PO8 to correct our assignment, make sure that we are all good with ordering integers, decimals, and fractions. So you needed to compare these using the less than, greater than, or equal to symbol. I know we did some together in class, but I don't remember which ones those are, so we'll just do all of them now. -7 is greater than -10. -4 is less than 2. -2 is greater than -9. -14 is less than -12. 19 is less than 22. 8 is greater than -8. -16 is less than -13. And -65 is less than -53. Any questions on those 8? Remember, a number line may have been quite helpful. You know, plotting that out, plotting where each number is, and just look, which one's further to the right, that one's going to be greater, which one's further to the left, that one's going to be lesser? Not sure that's actually a word, but order the integers from least to greatest. First, we have -8, followed by -6, -3, 0, 5, and 7. -8, -6, -3, 0, 5, 7. Next one, -10 is the smallest. So -10, -8, -3, -1, and +10. Just the exact order they would be in if this were a number line. Then the last one here, -15, -12, -8, -5, and -4. Questions on integers? Nay? Very well. We move on to decimals. Decimals, we talked about the stacking method. And the stacking method is a way, particularly with these last 4 here, to help you easily identify place value, okay? And just kind of use that to determine the order of greatness. 0.223 is less than 0.793. 67.4 is greater than 63.22. 2.54 is equal to 2.5400 because those extra zeros, they can be added forever, not change the value. 0.27 is less than 0.3. And here's just a quick example of that stacking method, right? If we stack them up vertically, the temptation here is to compare 27 to 3. Right? And 27 is greater than 3. However, this is 27 hundredths compared with 3/10, which when you put 3/10 out to hundredths is now 30 hundredths. And so 27 hundredths is less than 30 hundredths. That's how we got that answer there. 1.34 is less than 1.5 or 1.50. Ooh, that calibration was off. 2.361 is less than 2.365. 3.01 is greater than 3.001, and 10.999 is equal to 10.9990. Questions on those 8? Ones you want to talk about? You don't believe me on the answer? A challenge? You want a fisticuff? Yes, Aiden? No. All right. The bottom section here, ordering these from least to greatest. First is going to be 0.0884, followed by 0.879, followed by 0.884, and finally 0.89. Next one, 3.999 is first. Only 3 holes there, compared with 25 holes with the rest of the decimals. 25.3344 comes next, then 25.711, and finally 25.75. Third one, 1.2 is first, then 1.21, 1.23, and 1.25. And the last one, 7 holes will come first, followed by 7.295, 7.39, 7.4, and finally 7.96. Questions on those? Which one of those four did you find the most challenging? Raise your hand if you found the first one most challenging. Nobody. Raise your hand if you found the second one with all the 25s the most challenging. Okay. Third one with the ones. Fourth one with the sevens. Not everybody raise your hand. Polls only work if people vote. Otherwise, no. Okay. All right. And the final section of this page, fractions. Okay. So for these, there were a couple different methods that we talked about. Equivalent fractions could be used. Otherwise, comparing to 0, half, and 1. Either way you did it, 3/6 is equal to 5/10. Both of them simplify to be 1/2. 3/8 is greater than 7/12. I'm sorry. No, less than 7/12. We did that one together, actually. Less than 7/12. And we talked about how 3/8 being less than 1/2, 7/12 being more than 1/2. Obviously, the value that's less than 1/2 is going to be lesser than the value that's more than 1/2. So that's how we got that. 5/11 is greater than 14/33. You probably used equivalent fractions. You rewrote 5/11 as 15/33, right? Which is greater than 14/33. 9/5 is less than 7/3. For this one, those are both improper fractions. And we know that, 5 goes into 9 one time, right? So this value is somewhere between 1 and 2 because it goes into 9 once, but not twice. Whereas the next one, 7/3, 3 goes into 7 twice, but not 3 times. So its value is somewhere between 2 and 3. And that's enough for us to be able to tell that 9/5 is less than 7/3. Okay? You also could have gone for common denominators as well, but really just, something that's between 1 and 2 will be less than something that's between 2 and 3, right? Next one, 4/5 and 7/9. 4/5 is greater than 7/9. 13/4 is greater than 2 3/4. 2/7 is greater than 21/77. And 3/14 is less than 19/84. That's year I was born, by the way, 1984. Just realized that. Okay. Questions on those 8? Any you want to discuss? Not quite sure how I got the answer I got. Okay. Last section here. Orders the values from least to greatest. The first one, we have all fractions there. Well, I know that my two smallest fractions will be my two proper fractions, right? 4/9 and 2/3. Okay. 8/5 and 7/3, those will be on the greater end because they're improper fractions. They're both greater than 1. So 4/9 and 2/3, 4/9 comes first, followed by 2/3. 4/9 is less than 1/2. 2/3 is greater than 1/2. Then comes 8/5, which is between 1 whole and 2 wholes, because 5 goes in 8 once, but not twice. And then we have 7/3, which is between 2 and 3 wholes, because 3 goes into 7 twice, but not 3 times. Next one, we've got more decimals here. So let's see. First up is 1.542, followed by 1.567, then 1.59. Then after that, I'll go down to the next section here, our next row, 1.605, and finally 1.63. Then the mixture of decimals and fractions. These are pretty easy denominators to work with, either converting them to decimals or converting everything to fractions. So if I went all decimals, I'd have 0.45. 5/10 is 0.5. I have got 0.8. 1/3 is 0.33. And then 3/5 is 0.6. Okay, pretty easy conversions, and from there we can order them from least to greatest. If I went all fractions, 0.45 is 9/20. Then we have 5/10, which we could write as 20 as well. But 0.8 is 8/10 or 4/5. Then we have 1/3 and 3/5 there. And we could get common denominators pretty easily, 60 for those 5 fractions there. So either way you did it, you should get the same result. 1/3 is the least of those values, followed by 0.45, followed by 5/10, followed by 3/5, and then finally 0.8. So 1/3, 0.45, 5/10, 3/5, 0.8. Questions on any of that? If something popped up and you don't want to ask in front of the class, then on tonight's question form to go along with PO9, feel free to type in, actually, can we go back to PO8? I had a question on this one. Okay, so always feel free, whatever question you have, ask it in that form so it can be addressed. Okie doke. Okie doke. On to PO9. Adding and subtracting rational numbers, which of course we know that rational numbers includes integers, decimals, and fractions. And actually, I want to minimize this for a minute and just start typing or writing on the actual board here to talk about addition and subtraction. Okay, addition and subtraction is kind of the first math that you learned after just counting. You know, you have some amount, you add some amount to it. How much do you have an amount? You take away or whatever. And so your addition and subtraction questions look like this. You've got a number, then you've got something in between, and then you've got another number. That's not a hashtag, it's the number symbol for you 2020 kids, all right? And so this is what your standard addition and subtraction looks like, right? Now, what's in the middle here is important because that's the operation, right? That tells you what to do. That tells you whether or not you are adding or subtracting. And you grew up understanding that it was either going to be a plus or a minus, right? Plus means you add, minus means you subtract. But if you look at PO9, you see some other stuff there, right? On some of them, you see an addition sign followed by a subtraction sign in parentheses. Or you might see a subtraction sign followed by another subtraction sign, which is in parentheses. What do those mean? Right? So this is what you know, this plus minus stuff here, but this is what we're going to learn today. What are other ways to represent addition and subtraction? Okay? What I want to point out is that this number out in front here, okay, has absolutely nothing to do with the operation. The sign of that number, positive or negative, has nothing to do with the operation. This only tells you where you start. Where on the number line you are starting. How many you have initially. What you have to begin with. Then comes the operation. Okay? And this number here tells you how far on the number line you go. Right? You're adding 6. You're subtracting 5. Okay? It's how far on the number line you go. Okay? Again, the operation is what comes in between those numbers. Okay? The first time I see what I mean when we talk about this. What's your experience with the plus minus and the minus minus? The minus and the minus and negative. Have you seen those before? What you know what I mean? Okay. So let's start here then. We'll start with kind of the standard. Okay. When you add a positive,